Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul Prashala, Solapur. Actually, welcome to all of you in this video of 9th Mathematics Part 2. The topic is Surface Area and Volume Part 2. Friends, in the previous session of this video, we have been discussed with the lateral and total surface area and volume of three-dimensional figures like cuboid, cube and cylinder. Today we will discuss with the following subtopics of this chapter. That is curved surface area of a cone, total surface area of the cone, volume of a cone, problems from the practice set 9.2. Friends, let us start with the curved surface area of this cone. Cone. Friends, you can see in the figure cone. A cone is a three-dimensional shape that has a circular base and a narrow down to a sharp point called a vertex. One of the easiest real-life examples that could be given is a birthday cap in the shape of a cone. With regards to a cone, we have two types of areas. One is the total surface area and the other is the curved surface area. The total surface area of the cone is defined as the area covered by base and the curved part of the cone, whereas the curved surface area is defined as the area of the curved surface of the cone only. Friends, now let us see curved surface area of the cone. Here in this figure you could see R is the radius of the base, H is the height of the cone and L is the slant height of the cone. Friends, here the curved surface area of the cone is the area enclosed by a curved part. So if we consider here for the cone, R is the radius, H is the height and L is the slant height, then the curved surface area is given by curved surface area is equal to pi R into L. The slant height of the cone is given by L square is equal to R square plus H square. Let's now see total surface area of the cone. The total surface area of the area is the sum of the area of the circular base and the area of the curved part of the cone. In other words, it is the sum of the curved surface area and of this cone and the area of the circular base, which can be written mathematically as total surface area, that is TSA, is equal to area of the base, that is circular one, and curved surface area of the cone, that is CSA. Therefore, TSA, that is total surface area, is equal to pi R square plus pi RL, that is pi R into bracket R plus L. So in short, we can write TSA is equal to pi R into bracket R plus L. Now see volume of the cone. Friends, in the adjoining figure you could see the cone. If the base radii and height of the cone and a cylinder are equal, then 3 into volume of a cone is equal to volume of the cylinder. Therefore, 3 into volume of the cone is equal to pi R square H, which is the formula for finding the volume of a cylinder. When 3 brought to the right hand side, we will get the formula for volume of a cone. Therefore, volume of a cone is equal to 1/3 pi R square H. Friends, these formulas can be summarized here in the table. This is also called as a right circular cone. This is the figure. Curved surface area is pi RL, total surface area is pi R into bracket L plus R, and the volume is 1/3 pi R square H. Friends, now we will see practice set 9.2. Number 1. Perpendicular height of a cone is 12 cm and its slant height is 13 cm. Find the radius of the base of the cone. Given that height H is equal to 12 cm, length L is 13 cm, we have to find out the radius of the base of the cone. So here we have that L square is equal to R square plus H square. Substitute the values. 13 square is equal to R square plus 12 square. So 13 square is 169, which is equal to R square plus 12 square is 144. 144 it brought to the left hand side, it will be 169 minus 144 is equal to R square. The subtraction of these two is 25. So R square is equal to 25. Taking square root on both sides, we are getting R is equal to 5. So this is the radius of the base of the cone, which is 5 cm. Next, problem number 2. Find the volume of the cone if its total surface area is 7128 square centimeter and radius of the base is 28 centimeter. Here pi is equal to 22 upon 7. Friends, here given things are radius are 28 centimeter. Total surface area of the cone is 7128 square centimeter. We have to calculate the volume of the cone. Now we know that total surface area of the cone is given as pi r into bracket L plus R. Now we'll substitute the values. So total surface area of the cone is given 7128 is equal to 22 upon 7 into 28 into L plus 28. Therefore 7128 is equal to 22 into 4 into L plus 28. Therefore you can write L plus 28 is equal to 7128 upon 22 into 4. So friends, L plus 28 is equal to, after carrying this division, you are getting 81. Therefore L is equal to 81 minus 28. Therefore L is 53 centimeter. Now we'll find out by using the formula L square is equal to R square plus H square. Therefore L's value is 53, just calculated. 53 square is equal to 28 square plus H square. The squares of this 53 and 28 are 2809 and 784. Therefore 2809 is equal to 784 plus H square. Therefore 7809 minus 784 is equal to H square. Therefore H square is equal to 2025. Therefore H is the 45. Taking square root on both sides, we are getting the value of H as a 45. Now volume of the cone is equal to 1/3 pi r square h, which is equal to 1/3 into 22 upon 7 into 28 square into 48. Again we'll simplify here. So 1/3 into 22 upon 7 into 28 into 45. So after carrying the division, you will getting 22 into 4 into 28 into 15, which leads to 36,960. So we can write that the volume of the cone is 36,960 cubic centimeter. Now problem number 3. Curved surface area of the cone is 251.2 centimeter square and the radius of its base is 8 centimeter. Find its slant height and the perpendicular height. Pi is given 3.114. Friends, here the given things are radius 8 centimeter and CSA is 251.2 centimeter square. We have to calculate L, that is the slant height, and that of the H, perpendicular height. Friends, we know that curved surface area of the cone is equal to pi RL. Now put the values. Curved surface area that given 251.2 is equal to 3.14 into 8 into L. Therefore L can be written as 251.2 upon 3.14 into 8. So we'll remove this decimal point that leads to the step to 5120 upon 314 into 8. So 3140 upon 314. So L is equal to 10 centimeter. We know that L square is equal to R square plus H square. So we'll put L's value as a 10. 10 square is equal to 8 square plus H square. Therefore 10 square is 100 is equal to 64 8 square plus H square. So 100 minus 64 is equal to H square. Means H square is equal to 36. If you take the square root on both sides, you will be getting H is equal to 6 centimeter. So friends, here the slant height and the perpendicular height of the cone are respectively 10 centimeter and 6 centimeter. We will continue with problem number 4. What will be the cost of making a closed cone of tin sheet having radius of base 6 centimeter and the slant height 8 meter if the rate of making is rupees 10 per square meter? Friends, here the given things are radius is 6 meter and length of given as 8 meter. The cost of making the cone we have to find out. To find the total cost of making the cone of this tin sheet, first we need to find out the total surface area of the cone. And we know the formula, total surface area of this cone is pi r into bracket L plus R. Now substitute the values. 22 upon 7 into 6 into bracket 8 plus 6. So 22 upon 7 into 6 into 14, that leads to 22 into 6 into 2, which will be 264 square meter. Rate of making the cone is rupees 10 per square meter. So total cost will be total surface area into rate of making the cone. So 264 into 10 is 2640. So the total cost of making a cone of tin sheet is rupees 2640. Now we'll continue with problem number 5. Volume of a cone is 6280 cubic centimeter and base radius of the cone is 20 centimeter. Find its perpendicular height. Here the value of pi is given as a 3.14. Friends, here we know that the radius r is 20 centimeter and volume of the cone is 6280 cubic centimeter. Here we have to calculate the perpendicular height, that is h, of this cone. We know that volume of the cone is 1/3 pi r square h. Substitute the values. 6280 is equal to 1 upon 3 into 3.14 into 20 square into h. So h will be 6280 into 3 upon 3.14 into 400. So after calculation, 6280 into 3 upon 3.14 into 4. So friends, 20 into 3 upon 4, that leads to 15 centimeter. So the perpendicular height of this cone is 15 centimeter. We'll see problem number 5. Surface area of a cone is 188.4 square centimeter and its slant height is 10 centimeter. Find its perpendicular height. Pi's value we have to consider as a 3.14. Friend, here given things are length, that is 10 centimeter. Curved surface area of the cone is 188.4 square centimeter. To find perpendicular height h, here cone, we know that curved surface area of the cone is pi RL. So 188.4 is equal to 3.14 into r into 10. So r could be 188.4 divided by 3.14 into 10. So 188.4 upon 31.4. So here it is 1884 upon 314, that is 6. So r value is 6. Radius of the base is 6 centimeter. Now we know that L square is equal to r square plus h square. Therefore it can be written as 10 square plus 6 square plus h square. So 10 square is 100 and 6 square is 36 plus h square. So h square is 100 minus 36. That is h square is 64. Taking square root on both sides, we are getting h is equal to 8 centimeter. Means perpendicular height of this cone is 8 centimeter. We'll see now problem number 7. Volume of the cone they have given 1232 centimeter cube and its height is 24 centimeter. Find the surface area of the cone. Pi's value you have to take as a 22 upon 7. Friends, here given things are height you have h which is 24 centimeter and volume of the cone is given as 1232 centimeter cube. Here we have to find out the surface area of the cone. We know we have that volume of the cone is 1/3 pi r square h. Now we will put the values. 1232 is equal to 1 upon 3 into 22 upon 7 into r square into 24. So r square could be written as 1232 into 3 into 7 upon 22 into 24, which will be equal to 56 into 1 into 7 upon 1 into 8. So r square is equal to 49 you are getting after simplifying this step. Taking square root on both sides, you are getting value of r, that is the radius, as a 7 centimeter. Now we have L square is equal to r square plus h square. Therefore L square can be written as L square is equal to 7 square plus this 24 square. So it is 49 7 square plus 24 square is 576. The total is 625. Means L square is equal to 625. Means taking square root on both sides, you are getting L is equal to 25. Slant height L is 25 centimeter. Now curved surface area of the cone is pi r L. We have been calculated the value of r and L and we will substitute here, which will be equal to 22 upon 7 into 7 into 25, which is 22 into 25, that leads to 550 square centimeter. Therefore the surface area of the cone is 550 square centimeter. Now we'll turn to problem number. Curved surface area of the cone is 2200 square centimeter and slant height is 50 centimeter. Find the total surface area of the cone where pi is equal to, consider 22 upon 7. Friends, the given things are length, slant height, that is 50 centimeter. Curved surface area of the cone is 2200 square centimeter or 2200 square centimeter. Total surface area we have to calculate. We know curved surface area of the cone is equal to pi RL. Therefore 2200 is equal to 22 upon 7 into r into 50. So r can be written as 2200 into 7 upon 22 into 50. Little bit simplification, we are getting 100 into 7 upon this 50, that leads to 14. So r is equal to 14 centimeter. Now the total surface area of the cone is pi r into bracket L plus r. Put the values 22 upon 7 into 14 into bracket 50 plus 14. So 22 upon 7 into 14 into 64, which will be 22 into 2 into 64. The multiplication that leads to 2816 square centimeter. So total surface area is 2816 square centimeter. In word we can write the total surface area of the cone is 2816 square centimeter. So friends, now we will see problem number 9. There are 25 persons in the tent which is conical in shape. Every person needs an area of 4 square meter of the ground inside the tent. If height of the tent is 18 meter, find the volume of the tent. Friends, here the given things are h is equal to 18 meter. Number of people in the tent is 25. Area required for each person is 4 square meter. We have to find out the volume of the tent. Friends, every person needs an area of 4 square meter. It has been given. So of this ground inside this tent. Surface area of the base of the tent is equal to number of people in the tent into area required for each person. So 25 persons are there. 25 into 4 is 100 square meter. Surface area of the base of the tent is pi r square, which is equal to, that surface area given 100 is equal to pi r square. Therefore pi r square is equal to 100. We have that volume of the tent is 1/3 pi r square h. Therefore 1/3 into pi r square value is 100 into 18. So it will be 100 into 6, which leads to 600. So the volume of the tent is 600 cubic meter. Friends, now we'll see problem number 10. In a field, dry fodder for the cattle is heaped in a conical shape. The height of the cone is 2.1 meter and diameter of the base is 7.2 meter. Find the volume of the heap of the fodder. If it is to be covered by a polythene in rainy season, then how much minimum polythene sheet is needed? Pi is equal to 22 upon 7 and root of 17.37 is equal to 4.17. Given that height of the heap is 2.1 meter, diameter of the base d is 7.2 meter, therefore radius of the base r is equal to d by 2, which is 7.2 upon 2, 3.6 meter. We have to calculate here the volume of the heap of this fodder and polythene sheet required. Volume of the heap of the fodder is equal to 1/3 pi r square, 1 upon 3 into 22 upon 7, 3.6 bracket square into 2.1. So which will be 1/3 into 22 upon 7 into 3.6 into 3.6 into 2.1. After simplification, we are getting 22 into 1.2 into 3.6 into 0.3, and the calculation of this gives you 28.51 cubic meter as the volume of the heap fodder. Now we have L square is equal to R square plus H square. So 3.6 bracket square plus 2.1 bracket square is equal to 12.96 plus 4.14, that leads to 17.37. So taking square root on both sides, L is equal to 4.17. The value of root of 17.37 they have given 4.17. Now area of the polythene sheet needed to cover the heap of the fodder is equal to curved surface area of the conical heap, which is equal to pi RL. Put the values 22 upon 7 into 3.6 into 4.17, that leads to 47.18 square meter. Friends, therefore the volume of the heap of the fodder is 28.51 cubic meter and the polythene sheet that required is 47.18 square meter to cover the heap. Now friends, what we have been discussed today in this session is curved surface area of the cone, total surface area of the cone, volume of the cone, and problems from the practice set 9.2. Friends, will you try these problems? What is the slant height of the cone if the total surface area of the cone is 616 cm square and the radius is 7 cm? What is the height of the cone whose radius is 7 cm and curved surface area is 550 cm square? Pi is 22 upon 7. Find the total surface area of the cone with the radius 14 units and the slant height 8 units. Pi's value is 22 upon 7. Find the total surface area and the curved surface area of the cone whose radius is 7 cm, slant height is 3 cm. Pi value considered as a 22 upon 7. So these are easy problems. Calculate. Friends, you should not forget the famous words of George Cantor. In mathematics, the art of posing a question must be held at this higher value than solving it. So friends, with these words, I would like to say thank you.